Some Cryocene animals struggled to adapt to the Thermocene as the climate warmed rapidly from its previous cool average and the chilly polar regions blossomed into lush and more vegetated subtropical plains and forests. But the boarbird, itself a highly opportunistic omnivore with a penchant for eating the young of its own parent species, the canary, has managed just fine. Over the past 35 million years, these vivas continued down their novel route as increasingly small and cursorial carnivores. During the late Cryocene, their ability to run for long periods, freedom from dependence on grazing, and opportunistic ability to scavenge whatever they came across allowed them to cross seasonal sea ice across the Northern Ocean, reaching the island continent of North Ankiska. They thus survived the explosive and devastating burst of volcanism that occurred in Striata, kick-started the Thermocene, and caused the extinction of the other canary species. And though the new and unusual line, which would be known as gruffs, remains isolated upon North Ankiska today, they face few competitors here and so thrive as the dominant predator guild there. They are now highly cursorial, with nothing left of the wings but small stumps, but very long hind limbs, and their jaws are still sharply cusped and well suited to grab prey and tear flesh. Mostly solitary, they represent a remarkable shift of form and function from their early Cryocene ancestors that lived in herds and fed upon low-growing plants. There are a few species of gruff on North Ankiska today, the largest being only 250 pounds, paltry compared to its ancient half-ton ancestors. But gruff's size reflects a trend across this island continent, where all of the available prey today is relatively smaller too, no longer needing such massive bodies to keep warm in a milder climate. Additionally, gruffs must be lightly built, as they are pursuit hunters, capable of following herds of other flightless birds long distances until the weakest among them falls exhausted at the back and can be captured. As individuals invest so much energy into a single kill, they do not like to share, and all gruffs are territorial, though it is not rare for them to chase prey outside territorial boundaries and run into conflict with each other. Not all gruffs are active predators, though. The hooded bone bandit is the smallest of all, weighing only 60 to 80 pounds and standing just 3 feet tall. Closely related to a slightly larger species known as the common bone bandit, the hooded is nonetheless the most specialized member of the gruff lineage, for it is a nearly obligate scavenger. The quickest and most agile of all its group, it is able to supply most of its caloric needs simply by running in and stealing scraps under the nose of its relatives. The hooded bone bandit locates carrion with a powerful sense of smell and runs along the plains wherever it smells another gruff has made a kill. The rightful owner will invariably be protective of its meal, charging the bandit if it approaches. But so much more nimble is this small and sneaky animal that it returns again and again, having the advantage of being fully rested with all its endurance available, while the hunter is already exhausted from its prolonged chase. Once the hunter relents, the hooded bone bandit snatches a mouthful and runs to a safe distance to consume it, repeating whenever the predator lets down its guard for just a moment. The feathers on its face are very thin and sparse to prevent soiling with the entrails of the carcasses it feeds on, but also to let it radiate excess heat. Feathering has been reduced or lost on the breast, stomach, and the legs from the hip down for this purpose, in not just this species, but all gruffs, to better stay cool when hunting during the middle of the day. Even when the rightful hunter has its fill and leaves the kill, though, the bone bandit can still find use to the remains, for it is now the best adapted of all the gruffs to consume the hardest and least desirable remnants. The beak cusp closest to its face is now especially prominent and adapted to hold and splinter the thick leg bones of the local herbivores in order to access the nutritious marrow. This allows the hooded bone bandit to function as the cleanup crew of the northern grasslands. A variety of bird lineages can be found upon Serina 100 million years post-establishment. 100 million years have passed since the first canaries were brought to Serina. The birds have since evolved to fill virtually every niche their new world had to offer, from the largest herbivore on land to giants that swim the seas, and everything in between. Through the vivas, they have even developed their own version of live birth. Ancestrally, a large egg would be retained until just before hatching. In most modern vivas, the egg hatches inside the mother's body, and both the chick and the eggshell fragments are voided at once. Some of the largest land animals of the Thermocene are giant ceralopes known as ornithers. Descended from small, plains-dwelling grazing animals which evolved during the Cryocene, these live-bearing lipped birds, some of which reach heights of 20 feet and weights comparable to a similarly sized giraffe, have become large browsing herbivores which utilize hindgut fermentation to digest all matter of plant foods, unlike many smaller vivas which utilize rumination and eat a more selective diet. Like other ceralopes, their beaks are highly reduced to little more than a pair of incisors, which grow into one another like a rodent's teeth, ensuring they remain always sharpened for cropping tree branches and do not overgrow. Ornithers also exhibit highly specialized pseudoteeth. Like those of other vivas, they originate from keratin plates on the roof of the mouth and spines sprouting off the highly mobile tongue. In the ornither lineage, however, these structures have become very similar to the true teeth the bird lineage long ago lost. They are highly mineralized and coated in a protective layer of enamel, though the analog is not a perfect copy, for unlike the teeth of most truly toothed animals, all of an ornither's teeth grow continuously from the roots and must be torn down through use. They are all also fully capable of growing back if broken off for the length of the animal's lifespan. Ornithers chew their food by grinding a large anvil-like tongue covered in teeth against a matching set of molars in the top jaw. Most ceralopes also sport a set of tusks on both the upper and lower jaw, which, though usually used for defense, in some groups have a function as canine teeth to tear flesh as well, for not all ceralopes are vegetarians any longer. Above, ornither skull, showing teeth, chewing mechanism, and extent of soft tissue. Ornithers have large fleshy snouts, developed from the fleshy nasal sacs of early ceralopes, which provide an unexpected profile for a bird, but also an exceptionally well-developed sense of smell that allows the animal to make long migrations to find water, as well as seasonal food sources, such as the fruit of various plants that have evolved to use the giant birds to disperse their seeds. The habit of ceralopes in chewing their food before swallowing it, rather than grinding it to a pulp in a gizzard, as other giant birds such as cerastriders do, means that at least some seeds are likely to be swallowed without striking the tooth plates and pass safely through the digestive system unharmed. A wide variety of plants, including sunflowers and bamboo, thus produce large, fleshy fruit and seed pods, such as those of the sunflower tree above, with the intent of their seeds being swallowed and later deposited away from the parent plant by an ornithire. Fruiting bodies designed with ornithire dispersal in mind can usually be distinguished by their lack of bright coloration and strong odor, while those of plants which prefer to use other birds are usually brightly colored but not very fragrant, as few other birds have a particularly strong sense of smell. A variety of birds have specialized towards arboreal habits by the Thermocene, including groups which have long since lost their ability to fly, namely the vivas, which have continued to diversify ecologically from their ancestral niches. Several lineages have independently left the ground and climbed upwards into the canopy. Parrot-like vivas known as scramblers, top right in illustration, with hooked bills, large thumb claws, and strong three-toed feet with an opposable second toe which has evolved to replace the vestigial hallux, climb through the canopies of tropical forests, feeding on fruits and nuts. They are flightless but retain plumage on their wings, which is sufficient to slow their descent in the event they lose their footing. Unlike the ceralopes, they do not truly give live birth, but lay their single large eggs, usually in a tree hollow, a day or two before their chicks hatch. The chicks can climb from birth, but stay with their parents for as long as a year as they learn the tricks to survival, often riding on a parent's back when young. Other vivas have taken to the trees with very different niches and body plans. Visible clinging to the underside of the large sunflower tree is a very aberrant bird known as a cuckoo, which has totally lost its veined plumage everywhere on its body in favor of a short coat of downy fur, save for the crown on its head, where an erect crest of yellow feathers remains. In place of feathered wings, the cuckoo has evolved a skin membrane which connects from its large clawed hind legs to its short front arms, which sport two claws, the large viva thumb claw, and a new claw which has evolved from the fused second and third finger, allowing it to grip the bark of trees and climb with excellent dexterity. Though flightless, it can thus glide from tree to tree in search for insect prey, which it digs from under the bark of trees in the manner of an earth woodpecker, namely by hammering its large pickaxe of a beak into the trunk at breakneck speeds. Like the scrambler, it lays an egg several days before it hatches in a tree hollow and cares for the chick for several months. For even though it can climb through the trees from birth, it takes some time to learn how to feed itself. To the top left of the illustration can be found a pair of particularly bizarre arboreal avians. They superficially resemble scramblers, with large clawed wings, widely splayed hind legs, and long toes suited to grasping branches. but the relationship is only skin deep. Mucks are the small descendants of the enormous cerastriders, especially of the mountain-dwelling Nerebecs. Now known as mucks, they have retained and further specialized the very slow metabolism of their ancestor and decreased even further in size. Mucks are now some of the first totally ectothermic birds, largely unable to maintain their own body heat. By relying entirely on ambient conditions for warmth, mucks are able to get by on much less food, and less nutritious food than otherwise would be possible. Insulation is now unnecessary even for a small animal in such a mild climate, and in the case of the mucks would only provide a hideout for blood-sucking pests in the hot and humid rainforests common on Serina in the Thermocene. They have thus entirely lost their feathers, replacing them with the small, dry scales like are normally found only on a bird's leg, in a similar mutation to that which derived these scales from the feathered legs of their own dinosaur ancestors. Unlike scramblers, mucks have 4 toes, 2 facing forward, 2 facing back, which became longer and more opposable when the ancestors of the mucks moved permanently down into the valleys and into the trees, and out of the alpine slopes. Their curved hand claw is also not analogous to the scramblers, derived from a keratin sheath formed on the tip of the fingers rather than from the thumb, the sheath first adapted in their cerastrider ancestors as a defensive spike. Mucks, of course, also lack the chewing mechanism of the aardgeese and crop their food with the beak alone, grinding their very fibrous diet in their crops and fermenting them in a proportionally enormous stomach. Nerebecs only climbed trees to flee predators as infants, but now much of their descendants' time is spent hanging upside down in the trees, hidden from predators by their cryptic coloration, which resembled the moss-covered bark of jungle trees, though they are capable of short bursts of speed to flee danger, and are capable of leaping considerable distances from one perch to another if pressed. Mucks deposit their eggs, as many as 20, in warm patches of soil in jungle clearings, and exhibit no care for their eggs or their young, which hatch fully able to care for themselves. They have developed a total of 3 oviducts by branching the single one they ancestrally carried, allowing them to lay 3 eggs a day during the breeding period and reduce the number of dangerous trips the female must make to the ground by 2/3, from once a day for almost 20 days to just 6 or 7. Because of increased predation to watch out for in these tropical forests, the mucks have lost the binocular vision and forward-set eyes of their ancestor. Their eyes have moved back to the sides of their head to better spot stalking hunters. As the mucks are now so slow-moving and not inclined to leap at all, this is no major loss to them. A pair of small, long-legged birds with a brood of chicks can be seen foraging in the undergrowth beneath the large ornithine. With broad, flattened bills, they superficially resemble large ducks, but they are in fact small, basal cerastriders as well, only the size of small cranes. Unlike their giant relatives and the mucks which descended from said relatives, they still incubate their own eggs and raise their chicks, which are precocial but dependent on the adults for protection for several months after hatching. Normally, these little guys would be found wading along the edges of tropical and temperate wetlands in search of algae and small aquatic invertebrates to skim up with their bills. But the family here is depicted scavenging for fallen fruit or seeds which the large browser has dropped, nutritious additions to their diet which they likely couldn't access on their own. Two species of fairly typical flying birds can also be seen perched in the treetops. A large hornbill-like omnivore, able to fly but only poorly, joins the ornithire in eating the rich seeds of the sunflower tree. But this species is a seed predator. Unlike a larger herbivore, it performs no beneficial service, for it will crush and eat every seed it comes across, allowing none to pass through its system to germinate. Just below it, three more colorful seed-eating birds gather. Resembling large finches, but with some notable parrot-like attributes, their niche is as would be expected: seed eaters which crush their food in their large mandibles. Unlike the pseudo-hornbill, however, these birds are a bit small to manage the large pods of this tree, and eat a diet mostly of grass seed on the nearby plains, retiring to the forest only to roost. Not all ceralopes are as specialized as the ornithires. Rather, there exists a variety of lineages which diverged at different points in the group's evolution. Some still closely resemble the ancestral viva, though these have become rare and isolated over the eons. A greater number of groups are morphologically intermediate between these relatively primitive forms with large beaks and very little in the way of lips to speak of, and the most advanced ornithires and trunk snouts, with the underlying anatomy of their snouts heavily obscured by mammal-like soft tissues. These in-between primitive ceralopes show a reduction in bill size and unspecialized grinding plates on the roof of their mouths and lining their tongues. Though the structures are not mineralized as in the ornithires and some other advanced ceralopes, they are able to grind their food before swallowing, but have not evolved beyond the precursor to cheeks to hold in the bolus. Their mouths are lined, however, with thick, fleshy lips that in some other lineages did evolve into such structures, as well as into the strange trunks and fleshy snouts of their kin. The tongue, used to chew, is often partially fused to the lower jaw. The muscles of the jaw are well developed for the purpose of chewing food and bulge outward at the cheeks, lending the skull a somewhat triangular profile. Though more primitive than the ornithires and trunk snouts and other fleshly snouted vivas, the primitive ceralopes are still diverse and abundant by the Thermocene. The majority of groups are medium-sized, deer-like generalists of forest habitats, feeding mainly on fruit, seeds, and tender shoots, but also opportunistically preying on insects and small animals. Some species retain the large feathered wings of their ancestors, but the majority of surviving species have highly reduced arms. To make up for this, they have developed exceptionally long tails for purposes of maintaining balance, tipped in a fan of veined plumage. Often the last tuft of proper feathers retained on the body, otherwise covered in a fur-like coat of short, unbranched fibers. The combination of a short beak, lipped mouth, triangular skull profile, elongated tail, and primitive-looking plumage lend many of these species not only a comparable place in the ecosystem, but also in appearance very reminiscent to the extinct ornithopod dinosaurs of ancient Earth. More broadly, they hark back to appearances of the earliest dinosaurs, which would eventually give rise to all the clade's wide diversity, almost as if after several 100 million years, the birds have finally gotten over their rebellious flying phase and returned to their roots. Unlike any other dinosaur of the past or present, however, these neo-dinosaurs give birth to live young. Just one, as a mother can only carry a single egg at a time in her oviduct as it incubates. Because they produce relatively few offspring, all of the ceralopes are excellent mothers and protect their young ones until they are fully able to fend for themselves. In this respect, at least they are more akin to deer or other ungulates than to non-avian dinosaurs. The method used to process food is of course distinct too. Ornithopods using their teeth, and vivas having to circumvent the loss of their teeth by redeveloping analogous structures on their tongues. But the end result is the same. Because of the many superficial similarities, many of the ceralopes, which no longer quite look like proper birds, but haven't developed fleshy cheeks or snouts, are known as pseudo-ornithopods. Though the term is a paraphyletic classification, as it is used to refer to animals of several groups of only distant relations, whose closest relatives may not all fall under the same catch-all label above, though their common name may translate to false bird foot, and their appearance is more reminiscent of the non-avian dinosaurs of a bygone era than any modern bird. Do not be fooled. The pseudo-ornithopod ceralopes are as much descendants of the canary as any other bird on their homeworld. Here, a mother leads a very young chick through a temperate forest near Serina's North Pole. Just as winter has lifted and the buds and blossoms of spring begun to appear, providing abundant food just in time for the little one's arrival. Behind the pair, a long-billed, poor-flying ground bird, a probing insectivore of the forest floor, is startled into flight by their appearance in the clearing. The warming climate of the Thermocene has been very beneficial to the giant herbivorous canaries known as cerastriders, which rely on warm environmental conditions to incubate their eggs in the soil. Formerly able to breed only in a narrow belt of tropics near Serina's equator, the warmer global climate of the last 25 million years has now allowed them to spread from pole to pole in Serina's western hemisphere. The group has diversified ecologically in this time, producing a variety of new species, including horizontally set grazers with elongated horse-like skulls, semi-aquatic species which feed on aquatic foliage, and an increasingly varied tapestry of long-necked browsers adapted to feeding on a wide variety of plant species. The mucks, small, entirely featherless tree dwellers, are probably the strangest, but another of the most notable groups of the Thermocene are the pachyderm cerastriders. Pachyderm cerastriders are so named because, like the mucks to which they are related, as mature adults they are effectively featherless, instead covered with a very thick hide akin to that of a rhinoceros, which is often additionally ornamented with large knobs spikes, and scutes of keratin. Formed not from feathers or scales, but from the epidermis itself, these horny structures perform a defensive function, making it difficult for large predators to get a grip. What makes members of this group stand out, however, is not simply the loss of their plumage, but rather the process through which it occurs. Unlike mucks, chicks of this lineage retain feathers and come out of the egg with a full coat of plumage, but no longer the typical fuzzy down of precocial birds. For the first several years of a pachyderm cerestrider's life, until it grows large enough that the local gauntlet of small, fast-running carnivores no longer pose a regular threat, the bird is actually covered in a dense pelt of stiff bristles and long, barbed spines, which, like the keratinized growth of the adult, serve to make it an unsavory mouthful at best. The quills are long enough to reach past the armored beak of most avian carnivores and easily detach in the nostrils and near the eyes of potential predators, meaning that most small predators, which might normally be inclined to grab an otherwise defenseless cerestrider chick, will typically give those of this group a wide berth. Above, 3 specimens of a single species of pachyderm cerestrider, a large browser native to the tropical savannas of South Anquiska. From left to right, yearling chick still sporting a full coat of bristles. 8-year-old juvenile, beginning to develop horny armor over its body and having lost a majority of its spines, except for along its back. Adult male in breeding coloration, 15 plus years of age, almost completely without plumage, save for some small bristles on its rump, neck, and face, and now showing very pronounced body armor in the form of thick defensive plates and horny growths. The adult male also demonstrates the large defensive hand claw carried by most cerestriders as well as their basal kin, which can be folded out of sight into a fleshy sheath in the wrist when not in use. Young pachyderm cerestriders retain their plumage from anywhere from 5 to 10 years. The process of feather loss is not instantaneous, but rather occurs over several years' time, as the animal is also putting on mass and gradually developing its adult armor. The switch between quills and epidermal armor also goes hand in hand with the shifts in metabolism and ecology. Young individuals are active and lightly built, as well as omnivorous, consuming a wide variety of plant foods as well as invertebrates and small animals. They are long-legged and adapted to running and fleeing their predators at considerable speed, whereas adults are exclusive herbivores with long necks suited to browsing the treetops. They are also much more robust and less inclined to move quickly to escape danger. By the time most of its spines have been shed and replaced by armor, the cerestrider's metabolism will have slowed dramatically. It will no longer be able to warm its own body through endothermy, but instead will make use of its own bulk to do so through the process of gigantothermy. An adult rivals an African elephant in weight at maturity and will continue to grow half as much heavier again in the years that follow, granted at a much slower rate. And in the tropical climates these animals inhabit, this is sufficient to keep them active enough to fulfill their metabolic needs. An adult past the age of 15 years is already large enough that few carnivores can bother it, and those which otherwise could will find it a very difficult meal to handle. For all the gentle giant must do is turn its back to a potential threat, revealing the armored surfaces which most of its enemies will find very difficult to get a grip on. To further guard themselves from danger, adults move in large herds, which youngsters begin to associate with around the time they are 5 or 6 years old, just as their spines begin to shed. Until then, they live a solitary life in the jungle undergrowth. Adults are lethargic in comparison to juveniles, but do retain the ability to actively defend themselves. Even at full maturity, when they prefer a more passive approach to warding off danger. All cerastriders have large claws on their arms, which can give any predator a nasty lashing, and even a fully grown adult retains the ability to briefly balance on a single leg to kick out at a predator. The middle toe of both feet supports a particularly long claw which can disembowel anything that comes too close for comfort.